Assalamu alaikum, dear students. I hope you will be fine. After a long time, we are again going to discuss the course of signals and systems. Before this COVID-19 situation, we had a few lectures, a couple of weeks in fact, in which we discussed some basic properties of signals and some transformations which we apply on the dependent and independent variables. But since a long time has already passed, so probably you may have forgotten what we have already discussed. So we are going to start this all over again from the very beginning. So those lectures which we already took in the class, if you have them, you can still use them. But if you don't have them, or if you have forgotten what we have discussed in those lectures, so we are going to start all over again. So let's start the course of signals and systems. Due to the COVID-19 situation, this course is now being offered online, so we don't have any physical class setup. So this setting has some unique challenges both for me and as well as for you. The challenges basically, uh, the biggest challenge which I think you people may have is that the time now is very short. In fact, we have to cover all the course in roughly 8 weeks time. So normally we cover it in 16 weeks, but now all the courses have to be covered in 8 weeks time. So the course load will obviously be doubled. There would be 4 lectures per week, and similarly there would be 4 MS Teams sessions in which we will interact. And if you have any questions or you have any suggestions or problems, whatever, regarding the lecture which has already been uploaded, so we can discuss those problems in those MS Team sessions. So each of these lectures, which now you will receive as a recorded lecture, will roughly be a 50 to 60 minutes duration, and it may be divided into sub lectures. Like the first lecture may be divided into lecture 1A, similarly lecture 1B, lecture 1C, etc. One constraint is the size of the lecture, which will have some problems regarding uploading. So sometimes it is a bit problematic when you upload a large file due to slow internet connections and other reasons. So it may be divided, each lecture may be divided into sub lectures. Moreover, it is also difficult to view the lecture in one go, lecture of about 50 to 60 minutes duration. So it is more appropriate if we divide it into a number of sub lectures, where each of those sub lecture may consist of 10 to 15 minutes duration, and topic wise that would be more appropriate and it would be more easy for you to follow. with each lecture, for example, if lecture 1 is of about 50 to 60 minutes duration, there would be an associated team session, MS team sessions, in which we will discuss the problems or any particular questions which you have regarding those lectures. But please remember that the lectures will not be repeated in team sessions. So you have to view the lectures on YouTube, and then if you have any questions or any problems, then those could be tackled in the team sessions. But these lectures will not be re-delivered in MS team sessions. Moreover, to keep you motivated and interested in these lectures, there would be a simple quiz at the end of each lecture, and probably that quiz will be associated with the MS Team session, which will be taken with each lecture. And that quiz would not be very difficult. It would be a very simple quiz. So if you have attended the lecture and if you have viewed whatever has been discussed in this recorded lecture, it would be quite easy for you to attempt that quiz. So the advice is to listen these lectures, at least view them once, so that if you have any problems or any suggestions, or you should know what is going what we are going to discuss in each lecture, and that would help you to solve the quiz. Okay, so we will have a YouTube channel. Its address is given here, so you can subscribe to this channel, and each lecture which is relevant to this course will be uploaded into this YouTube channel. And as I already have said, that at least you have to view these lectures once. Course material of signal and system is sometimes boring, as I said earlier, so I will try to divide these sub lectures into small parts, where each part consists of 10 to 15 minutes duration, and particularly it would be around one topic, so that and that topic will I will try to make that topic as independent as possible, so that these short lectures can be viewed independently. Regarding MS Team sessions, I have already told you that it is mandatory for attendance. If you don't attend the MS Team sessions, your attendance will not be marked, and then you may not appear in the final examination. So it is compulsory for you to attend the MS Teams sessions. Moreover, the quizzes will also be taken in MS Teams sessions, so that's why it is again important for you to attend the MS Teams sessions. And further, if you have any questions, answers, or if you have any problems to understand the content of the course, then that can also be discussed in those MS Team sessions. So regarding books, we will follow mainly two books, Signal and System by Oppenheim. This is our recommended book, the recommended first book, and then another book which is Signal and Systems by Simon Haken. This course of Signal and System is a 4-credit-hour course, which means it has a lab as well. So normally the lab is the implementation of the concepts which we study in the course. The lab we normally use the software MATLAB, and we also discussed a little bit about MATLAB when you were present here in the campus before the COVID-19 situation. But obviously that was just a brief introduction of MATLAB. The more detailed introduction about the MATLAB and the lab sessions will also be communicated to you by your concerned lab engineer. But one thing which you must keep in mind, which you already knew, that labs are important because they have to be passed separately. So even if your theory course is, if you clear the theory course and if your lab is not cleared, then your course will also not be cleared. So it is important that you put considerable attention on the labs as well, which will be associated with this course. Okay, so just a motivation. Why do we need to study signals and systems? So you are engineers, not yet engineers, but obviously you are pursuing your studies to become an engineer one day, and hopefully inshallah you will become one day, you will be engineer. So engineers normally build systems which manipulate different kind of signals. The signals could be of different kind. They could be electrical signal, they could be mechanical signals, or such other type of signals could be there. So normally engineers build systems which operate on certain signals and produce a certain output. So for those systems, to study about those systems and to study about those signals which the system operate on, we need a formal framework for the study of signals and system. That framework is helpful to inform us, to tell us about the specifications or the requirements of a certain system which we may want to develop. So if, for example, we do this thing without any mathematical formulation, then there is a chance that system may fail. And if system fails to perform as it was expected to perform, there could be some negative consequences. And in some situations, those consequences could be quite catastrophic. So the techniques which we will discuss in this course will help you to know the techniques which we will discuss in this course will help you to have a grasp on those mathematical foundations, on those mathematical frameworks which are necessary for the design and analysis of systems. So that is basically the main motivation behind this course, and in the systems which we will encounter during the course of this study, you will know that these systems are all around you. Even your simple electrical circuits can be considered as a system which takes one input and it may produce one output. So these systems are all around you, and in your career, in your engineering career, you will encounter about these systems a number of times. So in order to design and analyze those systems, you must have some framework with which you should be able to design, and that framework will be introduced in this course. This course of signal and system is also a prerequisite course for a number of courses which will follow in the coming semesters, like the course of digital signal processing, or the course of principle of communication, or the course of control systems. So all of these courses have this prerequisite course, signal and system. So it is very important to pay full attention to the study of this course and to clear it within this semester, so that in the next semesters the courses which are based on this signal and system course, you can take them and you can clear them. Okay, so what basically you should expect, what we are going to discuss in this course, and what are the main constituents of this course. So in this course we will, as the name implies, we will basically talk about signals, and we will also talk about systems. So signals can be divided into various categories. There could be even signals, odd signals, continuous signals, discrete signals, periodic and aperiodic signals, energy and power signals. So we will talk about different classes of these signals. And similarly, the systems which we will encounter in this course can also be divided into a number of different categories, like there could be some linear systems, some time invariant system, causal systems, stable systems, invertible systems. So number of different categories they fall into. That could also that we will also discuss in this course, the various types of systems and various kinds of signals. Moreover, when we analyze signals, or when we analyze the systems, there are basically two kind of analysis which we can perform. One analysis is called a time domain analysis, in which the signal or the system is analyzed in the time domain. For example, if you give an input to some system, so what would be how that system will behave, how the output will appear after how much time, after how much time the output will appear, after how much time the output will get stable. So all these things which we are going to discuss in this domain, in time domain, are basically related to such kind of concepts. But then these signals and the systems can sometimes be more conveniently analyzed in another domain, which is called frequency domain. So we should know the tools which will help us to move from one domain to another. And in this course we will also discuss about those tools, and you will see that we will talk about the convolution. We will basically, convolution is a type of shifted multiplication, and the importance of this convolution, which we will discuss in detail in this course, is that if you are given the impulse response of any system, impulse response of an LTI system, for example, more specifically, if we say an LTI system is type of a system which is linear and it is also time invariant. So it has a unique characteristic. Each LTI system has something which is called its impulse response, and we call it as h of t. So this h of t, impulse response of system, if you know the impulse response and you know the input signal which you are giving to this system, can you predict what would be the output of that system? So the question is, given the impulse response and the input of the signal, can you tell about the output which that system will produce? And the answer is provided by this convolution mechanism. So convolution, if we talk about continuous time systems, we have two kind of systems. When we will formally discuss these things, you will come to know that the systems or even signals are divided into two major categories. One is called continuous time and one is called discrete time. So if you have a continuous time system to which you are giving a continuous time signal as an input, then the output can be determined by this convolution integral. Similarly, if you have a discrete time system to which you will normally give a discrete input, then the output can be determined by this convolution summation. We will also discuss some properties of the LTI systems, which in terms of its impulse response. Uh, you may know that we have already talked about system properties a little bit, but those system properties were general system properties, like when the system is stable, when the system is causal, when the system is invertible, when the system has memory or it is a memoryless system. But all these attributes of the system can also be determined in terms of impulse response. So impulse response of a system has some unique properties, and in some way it can tell about those system properties. So we will also discuss the properties of LTI systems in terms of their impulse responses. Now moving forward, and important, as I already have told you, that the study of signal and systems is basically, in this course we will also discuss some transformations, some transforms, and one of the basic transforms is called Fourier transform or Fourier series. For example, if your signals are periodic, so Fourier series helps us to visualize things in a slightly different domain as compared to the time domain. We may have some properties, we have discussed them in the time domain, but we want to study or analyze certain aspects in some other domain. For example, your input signal, what are the frequency components which it is made up of? So how many different frequencies are present in your signal? So time domain normally does not provide any information about the frequency content of the signal, but if we transform it either by Fourier transform or Fourier series, and that can help us to determine what are the frequency contents and of our signal, and that has number of different application. For example, here we have written filtering is one such application. Filtering is a process where you remove some unwanted frequency components of a signal. So for example, if you have a low pass filter, we want to remove the high frequencies present in the in that signal. So before that, first we should know कि हमारा जो सिग्नल है वो किन फ्रीक्वेंसी से मिलके बना है. सो इस तरह की जो चीज़ें हैं, जो इस तरह के कंसेप्ट्स हैं, इनके लिए हमें अपने इनपुट, अपने टाइम डोमेन सिग्नल को जो है वो उसके फ्रीक्वेंसी कंटेंट के बारे में मालूम करने के लिए हमें कुछ ट्रांसफॉर्म चाहिए, और ऐसा ही एक ट्रांसफॉर्म जो है वो फोरियर सीरीज़ है या फोरियर ट्रांसफॉर्म है. छोटा सा difference, a very slight difference between Fourier series and Fourier transform is that if your signal is periodic, then we will apply the Fourier series for analysis, and if your signal is aperiodic, we will be applying Fourier transform. But these are the two main topics which we will cover in this course: the Fourier series and the Fourier transform. So Fourier series is basically the representation of periodic signals. We will also discuss some more things like convergence properties of Fourier series and frequency spectra, Fourier series applied to LTI systems. So these two main topics are Fourier series and Fourier transform. The only difference is that one is applied to periodic signal, another one is applied to aperiodic signals. So otherwise they are more same. They help us to visualize our signal in a different domain. The next is something which is called a Laplace transform. A Laplace transform is basically applied uh, to our systems, to our system analysis and to our system study, and it helps us to determine uh, what is the behavior of our system stability is a system property which we will discuss in the time domain, but we also want to know, okay, हमारे system की stability, if for example our system is unstable, तो क्या चीज़ है जिसकी वजह से वो system unstable है. So here we will learn about something which is called region of convergence, and here we will learn about poles and zeros of a system. So lot of system parameters जो हैं वो हम यहाँ पे study करेंगे. And again the Laplace transform is a mathematical tool which will help us to transform our system into a different domain and to study or to analyze its properties over there. So briefly we will learn in this course about signals, various kind of signals, about various kind of system. Particularly we will pay our attention to systems which are linear and time invariant, and they are basically called LTI systems. So we are interested in the study of LTI system because most of the times the system which we encounter are LTI in nature, so we are more interested in their study. And then the transforms, the Fourier series, the Fourier transform, and the Laplace transform, which is a mathematical formulation to convert, to study, to analyze the properties of our signal and system. So hopefully this was just a brief introduction. From the next lecture we will formally start the course of signal and system. We will start our course from defining what is a signal, how many different types of signals are there, what are the properties of signals. So all these things we will be going to discuss inshallah in the next lecture. So hopefully you should remain with me. If you have any problem we can discuss in MS Teams sessions, but the bottom line is you have to attend these lectures. You have to subscribe to the YouTube channel so that all lectures could be accessible, and you have to view them, and if you have any problems or any questions we can discuss them in MS Teams sessions. Thank you very much.